First off, we're taking a look at my circuit for my mood ring. I've got the LED right there. It's grounded with that green wire, and then I've got a 5.1 kilo ohm resistor from the blue pin to pin 9, and then from the red pin to pin 12. And then over here we can take a look and we can see my thermistor. The thermistor is grounded on one side with the green wire, and then it's got a voltage divider 20 kilo ohm resistor on the other side to VCC. So the rest of the cables, both greens are ground, yellow is test, and blue is reset, and the red one is connected to my VCC on my launch pad. So let's go ahead and take a look at the code. First, what we're going to do is we're going to debug. And then we're going to play. And here you can see that the LED is blue. And then as I apply high temperature, you can see it starting to turn red. Let's just get a better angle, see if we can improve the color for the LED change. So I'm going to apply, as you can see right now it's blue. I'm going to apply some temperature. See how it turned to red real quick. There we go. You can sort of see the color change at least. Looks pretty red. I release. It's going to start turning blue slowly. That came out better from this angle on the camera. Go ahead and give you a quick walkthrough of my code. Basically what I've done is I've broken it up into 3 different functions plus the 2 interrupts to just make the code a little bit neater and more readable. The first function is just sets up all the clock controls. So basically what I've done is that for my TA0 I've got my I've selected to use the auxiliary clock, and I'm going to count up to my CCR0, and then I just enable the CCR0, and then I say the number of clock cycles I want to count up to is going to be 1024, and then we just go ahead and enable the interrupt. And then for TA1 what we're doing is we want to use the SM clock, and then again we want to count up to CCR0, which we have indicated as 100. Next we're taking a look at the code for my basically just setting up the controls for the output. So here we've got for the output for the LEDs, we can see that for the red LED we've set up the timer to reset set mode, and then we've just set the direction and selection of port 2 with bit 4, and then likewise for the blue LED we've also set it up the timer to be PWM reset set, and then we've just set the direction and selection of port 2 to bit 1. We're looking at the code that sets up the ADC10 and its controls. So what we're doing on that first line basically is we're enabling the ADC10 and its interrupt, and then we're setting its references, and then we're multiplying the clock by 2 to 4 with the ADC10 SHT_0 command. And then on the next line we're just selecting that we want channel 5, and we're doing the 0 select for the ADC10 clock. And then that last line we're just go ahead and did the ADC10 analog enable. This is where we wrap everything together here in the main loop, and we just, as usual, we turn off the watchdog timer, and then we set the frequency to high, and that we want to source the VLO from the auxiliary clock. And then the next 3 lines just call the methods that we previously talked about. And then the last line tells the MSP to go ahead and enter low power mode 1 with allowing for interrupt. Lastly, here we see the 2 interrupts that I've created. On the first one, all I do is enable the ADC conversion, and then in the second one, this interrupt is for the ADC, what we do is that variable sampled was actually initialized as a global variable before all the functions that we created. And then what we do is that we take a sample measurement, and then using that sample measurement as a reference, we create a mapping from 0 to 100 in order to calibrate the LED color mapping to the temperature. So basically is that it calibrates what will be considered a low temperature and what will be considered a high temperature, so that way when we touch the LED, when we touch the thermistor, we'll see it go to red, and let go, it'll go to blue, and this is where that calibration is happening there at the bottom. It uses that reference value that was sampled to create that mapping for the LED color and temperature.